This presentation is about density, mass and volume. There's the equation, questions and answer at the end. There's some more resources if you want to go and have a look at my shop on the Times Ed supplement. The link is below. Please don't forget to press like and subscribe. So definitions. Density is measured in kilograms per cubic metre. It's the mass per unit volume. And mass is the quantity of matter in an object, or a measure of how difficult it is to change the velocity of an object. That's often called the inertial mass. Now, density can also be given in grams per centimetre cubed. And the question will usually ask you which, or tell you which it wants you to work in. I'm going to give you the working in both of these, just so you've got an idea. The equation for density is mass divided by volume, and it's usually given as a rho equals m over v, which you can rearrange to mass equals density times volume, or you can have volume equals mass divided by the density. Now, just to go over the differences between grams and kilograms, we have 1 gram equals 0.001 of a kilogram, making 1 kilogram equal 1,000 grams, because K stands for kilo, which is 1,000. However, when we're looking at centimetres cubed or metres cubed, it's a little bit more difficult. So how many centimetres are there in a metre? So 1 centimetre is 100th of a metre. So 1 metre, or 1 cubic metre, is 100 centimetres by 100 centimetres by 100 centimetres. So it's 1,000,000 centimetres cubed. Or, if you want to look at the other way, 1 centimetre cubed, or 1 cubic centimetre, equals 0.0000001 of a metre cubed. So that might help you work in the different units. But I'll go through the questions in a few minutes anyway. So, if you want to pause the presentation now and have a go at the questions before I go through them, that's the best way of doing it. Otherwise, I'll be going over them in a second or two. Okay, a student measures out 95 millilitres of a liquid, then pours the liquid into a beaker of mass 110 grams. The beaker and liquid has a mass of 197 grams. What's the density of the liquid, and will it float on water? So this is assuming that we know what the density of water is. And the density of water, if you need to look it up, I'll give you a bit of time to look it up now. So we don't need to change these units very much, but we do need to work out the mass of the liquid. So that's the first thing we need to do. Mass of liquid equals 197 minus 100, it's 110, which equals 87 grams, or 0.087 kilograms. And the volume equals 95 millilitres, which equals 0.0003495 of a metre cubed. I think that's right. So density, mass divided by volume, which equals 87 divided by 95. I'm going to work in grams and millilitres. I never said that, did I? 1 millilitre equals 1 centimetre cubed, which equals, if you do the maths, it's 0.91578, which we're working to 2 significant figures here. And we've got 3 significant figures there. So it's 0.91. Well, we'll go with the 2 significant figures, 0.92 grams per centimetre cubed to 2 significant figures, if I'm not asked to be any more accurate. For the next part, I'm going to do it in kilograms, 0.087 divided by, I haven't written it down again because I've written it down over there, just to the side, divided by 0.0000095, which equals 915.78 kilograms per metre cubed, which to 2 decimal places is 920 kilograms per metre cubed. I hope that helps you. So where would the marks be? You'd get 1 for the equation, 1 for the substitution, 1 for the correct answer, and 1 for the units. You would also have a mark for changing these to the correct requested values. Next question. A student placed a stone in a displacement can and it displaces 230 millilitres of water. So again, a milliliter equals a centimetre cubed, so that's 230 centimetres cubed. Its mass is then taken on a balance at 750 grams. What density does this give for the stone, and what mistake has the student made? So let's have a look at the density first. Rho equals mass over volume. And we've got the mass straight there, which is 750 divided by 230, which is the centimetres cubed part. And that gives us a density of 3.2608 grams per centimetre cubed, which when we work this out, we've got 2 significant figures there and 2 there. So it's 3.3 grams per centimetre cubed. Now, if we have to do that in kilograms, it would be, I'm not going to write the equation out again because it's just at the side. Its mass is 0.75 in kilograms, and the volume is 0.00023 in meters cubed, or cubic meters, which gives us an answer of 3260 kilograms per meter cubed, which is 3,300 kilograms per meter cubed to 2 significant figures. So where are the marks? Again, we've got 1 for the equation, 1 for the substitution, 1 for the answer, 1 for the units. Now let's have a look at this second part. What's the error? Well, the student puts the stone in the displacement can first and then weighs it afterwards, so the stone will be wet when the student takes the mass. And if the stone is wet when the student takes the mass, the density will be too high. So it'll lead to the density being too high, because the mass is too high, because it includes the water that's on the stone as well. Okay, I hope that's been useful to you. Don't forget to look at my resources available on the Times Ed, and don't forget to press like and subscribe. Thank you for your time.